all analysis will start with the benchmark, the current situation. What is the current situation for this load center? Well, what we have here is the results of the reliability assessment, which is the model basically models all combinations of failures in the network. Basically, you tell it, okay, if something has a probability of failure less than, let's say, 0.001%, then you can ignore it. Otherwise, consider it. So it runs all of the combinations, single failures and combinations of failures. And then this is what we got, that there is an expected frequency of interruptions of load of 0.24 times per year. Each one would have a duration of, each one when it happens would have a duration of 3 hours. And the expected value, which is the multiplication of these two, is 45 minutes a year. So this load would have an expected interruption in this example of 45 minutes per year, given the cost of then converting that into energy not served, that gave us 400 megawatts of energy not served and a cost. So that was our base cost of analysis. Again, on a real system, these values may be a lot smaller, but I make them high so we could see the impact. And the other aspect that it tells us is that for those minutes per year, that's 45, the lead contributor, and where we should put the box is in the line 171. The other contributor, which is the next place to put the box on, would be the technology park, substation B, which is where the generation was located. And that gives us this total for 4576. So that's our benchmark case. That's the case without the data center. Now we build the data center. Well, things get ugly very fast. For the existing load, there was not a significant impact. The expected duration increased from 45 to 47. So yeah, there was an increase in cost for it because there was an increase in energy not served. But look what happened for the data center. Now it has expected duration of 47 minutes per year.
Nelson, there's a question in the chat about whether you're considering both replacement and repair costs or only the repair costs.
In this case, basically what we're considering right now, and we'll be considering of adding assets. In this case, we're not considering aging infrastructure and then upgrading it or replacing it. It's just adding new assets to address the issue. So the case that I presented is a system the case that I'm presenting right now is a system the way it is. And we can see that for the 47 minutes of interruption, 44 minutes are due to the line 171, that line failing, creating an overload somewhere else in the system, and having to shed load to address that overload at the data center. The next would be the technology park sub A. And then there was another substation inside the system that was also responsible for the interruption. So it's basically the system the way it is, and the cost that we're considering is just the cost of adding new assets. For each asset, we're considering its failure rate, its repair time, and also for some assets we consider the maintenance, but typically the maintenance done off-peak. But for example, when we are considering generation, then we typically put there a maintenance period. All right, so that's our situation. We have 47 minutes of interruption because of this large load that we're supplying, then we're talking about an energy observed of over 1 gigawatt hour, or $17 million per year of cost to the load for not having these investments.